Flaky tests. One of my favorite topics. All right, so I'm going to start by defining what a flaky test is, because I think we use this term a lot without really thinking about what's going on. I see a lot of people using the term flaky tests and brittle tests interchangeably when they're different. So like, what are these and how are they different? A flaky test is a test that is sometimes passing and sometimes failing. And there are a number of reasons for why this might be sometimes passing, sometimes failing. We'll get into those in a bit. It's different from a brittle test because a brittle test is something that once it has started failing, it's never going to pass again. So what your tests are doing is you're testing the state of a website. And if the website makes an actual change, the designers go in and change class names to make it look different, or you add content and add a different feature, change a feature from one thing to another, you're going to need to change your tests to accommodate that. Sometimes there are changes that are made that aren't related to your tests, but your tests will now start to fail because the locator changed. So think about like a hard-coded absolute XPath, right? You put that in there. If you change anything on the site at all, change any part of the DOM, that element's no longer going to be found. It's going to be pointing somewhere else. And so you want, if your test relies on something brittle like that, it's going to fail. And so the idea is that you want your locators to be flexible. You want your tests to be able to handle minor site changes, legitimate actual site changes that shouldn't affect the functionality of the site, right? Your test is supposed to be testing whether the site works. And if the site still works after some random change to the site, but your test fails, that means your test was brittle. It wasn't able to manage that minor site change. And this is also where you get into the idea of self-healing tests, where, oh, the site made a minor change, something moved around, it would fail, but because we have this magic self-healing, it actually found the element that we intended it to find, and the test has proceeded as we want it to. The problem with self-healing is it's impossible. Well, the computer itself doesn't know what you're trying, what the intent is of what you're doing. It's making a guess. And in some cases, that's fine. In some cases, it might not be. I know one of my colleagues absolutely has gotten one of the self-healing, some of the self-healing software to them. He made a change to the site and ran the self-healing thing, and it picked the wrong path and went down the wrong thing. So the system was broken, but he got the test to pass because it self-healed to the wrong thing. So you just have to be very careful that you understand if you're using some kind of self-healing, what it's doing and why, and understand the context in which it's going to be applied, and just be careful. You don't want to have a false sense of confidence, like the CrowdStrike instance where they had some tests that were passing but weren't working correctly, right? So you have a false sense of confidence. Everything's passing, good to release, except what we thought was passing wasn't actually representing the actual state of the system. So flaky tests, intermittently failing, brittle tests, once they've started failing, they're never going to pass again because something on the site changed and your tests weren't flexible enough to adjust with them. So different aspects of flaky tests, there's a bunch of different ways that your test could be flaky. The first thing is making sure that your code is deterministic, making sure that you're following the same path in your code. I've worked with a number of frameworks over the years that would look at the state of the system and try and guess what the next thing should be done. Oh, we're in a flow. So if you see do the automatic form fill, and if you see a next button, clicks the next button. But if it's not a next button and it's the finish button, then click that button. And the problem is, if there is any point in time where you get out of sync even slightly, you're now just down the wrong path. It was supposed to click the next button, but it didn't see it quite in time, and so it's on to its next thing. Make sure that there's one path. Your test knows the flow to accomplish what it's doing. We're not doing chaos testing for this. We're not just throwing a bunch of stuff and seeing if there's any errors. You have a flow that you're saying, does this specific thing work? And here are the exact steps to make sure that that specific thing works. So make sure that your code is deterministic, that it's not relying on the state of the system. See the same thing with you'll see, like if you're doing mobile testing, and I've seen people use the same code, and it's like, oh, if you see the mobile element, then go down the mobile path, and if you don't see the mobile element, go down the desktop path. And I'm like, you know how you're running you know what you're testing when you're testing it. Like either it's a configuration difference, or like just check the driver. If it's an Appium driver, do the mobile thing. If it's a Selenium driver, do the desktop thing. It doesn't make any sense to try and guess at what you already know based on the state of a system that's not necessarily reliable in any given moment that you're checking. So another issue is what you're testing from the CI server. So a lot of times I'll see people try to run 200 tests in parallel in different threads and processes with Java on the same CI server. And if that CI server doesn't have a lot of memory and a lot of processing power, it's not going to work very well. This is people like, oh, how many can you run in parallel at a time? Like it really depends on how processor intensive the work that you're doing is, how large the computer that you're running it on, and if that has to change. So you might have to run your tests in parallel in multiple builds on multiple CI nodes of some kind. Same thing, what you're testing against. Last company I worked at, all of our automated tests were failing. DevOps made some change, and like all of our tests start failing. I'm like, what's going on? I talked to DevOps, and he's like, oh, I didn't realize you were running automated tests on this. Oh yeah, no, we're using the cheapest AWS server you could possibly get to host the staging environment for you to test against it. I thought you were just clicking around. I'm like, no, we're trying to run 100 tests at a time. He's like, okay, that's not going to work. We're going to have to change that. So I see it very frequently, even on large staging environments. People are like, oh, I'm getting all these errors. I'm like, how many are you running at a time? 200. All right, how about you drop it down to 50? Do you still see all those errors? Like, oh no, they all went away. I'm like, all right, so let's figure out if it's your CI server that's having a problem, or if it is the system under test that just can't handle that load, and then figure out how to address it from there. And finally, the last thing, this used to be a bigger deal, I think, than it is to some extent, but one test can affect another test. You can have cookies set in one test that shouldn't be there for the next test, especially if you're trying to run without any order to your tests, things like that. And so it's entirely possible that your tests are flaky because some state from a previous test has affected the state of the current test and put it outside of the preconditions for that test. And so this is something where Sauce Labs comes in handy, is you get a brand new session every single time on a brand new virtual machine container. You get exactly a known setup every single time you start a new test. So test data management is really one of the big pieces here for making sure that your known state is good when it comes to the data that you're working with affecting the test execution itself. So the classic example here is I call it grab and hope, right? You're going to run a bunch of different tests, and you're just like, hey, I just need the reservation. So like, just grab the first reservation on the list and then test with that. Well, if you have two different tests running at the same time and they're each trying to do something to the same reservation, one of them is probably going to fail. And so you see this a lot when running at Sauce Labs, like, hey, run a whole bunch in parallel. If people have written their tests assuming that they're running one at a time or running in a certain order, this can cause a lot of problems because the way they're managing their data isn't independent. And so that's either just grabbing something and trying to use it and hoping that it's going to work out, in which case you end up getting flaky tests. Like, when I run it in parallel, it fails, and when I run it by itself, it passes. That's flaky. That's a type of flakiness. And then the more advanced ways that I see a lot of people doing is static reference or dynamic fixtures. This is essentially just maintaining a large, I talk about this in other places, but it's just maintaining a large list of what tests use which data with which specifics, and it just gets complicated to maintain. And you're not necessarily guaranteed that you're not going to have any collisions still, even with all of that. So my recommendation, you can read about it, or I can send videos if you need, for just-in-time data management. This is have every single test generate all of the data that test needs for that test. So each test is responsible for all of its own data. It does take a little bit longer depending on how you do it, and there's shortcuts for this, but you can set state with all of the test data that you need for every single run, and that will improve your flakiness issues significantly because you don't have to worry about, oh, maybe I just ran those two, like let's rerun it, let's just run everything in series. If the test data is independent because it's maintained at the time of the execution, then you don't have to worry about any of those conflicts. All right. The primary reason for flakiness, the primary thing that we are working with is just synchronization issues, right? So most of the time when there is a flakiness issue, your computer code tried to execute something that the browser wasn't ready for. So the page hadn't quite finished loading, the element hadn't quite shown up yet. You tried to do something before the next thing actually finished. There's 4 different ways that we do synchronization. The first is you get the 2 local and then the 2 global. The local ones are sleeps and explicit waits, and the global solutions are implicit waits and abstract waits. So let's walk through this real quick. So sleeps. Everyone knows you're not supposed to use these. They're bad. The problem is either you're sleeping too long or you're not sleeping enough this time, right? So you either have huge performance problems and you still might have unreliable issues because, hey, if you just waited 0.5 seconds more on that one, everything would have been fine. And then you just have huge performance issues. It's impossible to get know exactly what the right middle ground is for these. At the same time, for certain things, that might just be the easiest. Just throw a couple seconds sleep in there, and that fixes the immediate problem. Really depends on the context, depends on your framework, and depends on how much time you have to deal with some of these issues. It's a band-aid, it's a crutch that you don't want to over rely on. All right, implicit waits. Love the idea here. This is built into the WebDriver specification. The idea is you go to locate an element, and if the implicit wait is set to 0, which is the default, the driver will immediately error and say, element not found. Implicit wait just says, well, how about wait up to 2 seconds before telling me that the element's not found? And so if it finds it right away, it'll return it right away. But if it doesn't find it, it'll wait up to the time of the implicit wait setting before it comes back and says, yeah, no, I can't find it. So and the way this works with the W3C standards, you set this in the options at the beginning, right? I see people setting it and unsetting it throughout their test code. Just set it if you're going to use it, set it at the beginning of the test and then don't touch it. So with one line of code in the Chrome driver options, you can have it apply to the rest of your test. And so there's problems with implicit waits. Implicit waits don't play well with hard-coded sleeps. The issue with implicit waits is you kind of lose control of the waiting in your code because you've seeded it to the driver or a remote server. So it makes it harder to debug things. You can't dial into things while you're working with it if there's an implicit wait everywhere. So it's global, which is good, but also that means the places where you just want to dig into something, you have to wait for the implicit wait to do its thing in some cases. You end up with weird loops with explicit waits and implicit waits mashed together. So it's a good idea with some implementation issues and some general frustrations. But if you have a lot of flaky tests, set a 1 or 2 second implicit wait at the beginning. Our numbers at Sauce Labs show that people that use implicit waits have a higher failure rate. They report more failures than people who do not use implicit waits, which is a pretty good indication that you shouldn't be using implicit waits. But it's one line of code. Give it a shot. If it makes things better, you can now spend time figuring out why you needed that in what places, right? So it's a tool that you can use to improve your overall flakiness situation, your overall synchronization approach. All right, explicit waits. This is the gold standard. This is what everyone says to do. This is essentially figure out exactly what you need to wait for every single time you need to wait for something, and then wait for it, and then move along. And so often this is the presence of element located kind of methods. We have expected conditions in a couple of the bindings. Explicit waits are great, except for you end up putting them everywhere and you end up missing things a lot of the time. You oh yeah, no, that I just need to wait for that. In water, we had a method called wait until, or when, what was it? It was when present. So you define the element dot when present dot click. And then I'm looking at that when we were trying to redo for water 6, like, wait, why, as a tester, why would I ever want to click an element that wasn't present? That seems silly. Why can't this code be smarter about it? Water is supposed to be a do what I mean kind of a framework. And so, like, if I say click it, then it should try and make an effort to click it. And so we got rid of all of those and tried to make it, yeah, everything is when present. And then when we made that change, I got a lot of feedback from a lot of people about just how much of a difference it made, because a lot of the times you forgot the when present method, right? You forgot to add that explicit wait in there. And so every single time you're taking an action, you need to have that in there, or else if you don't, then you're like, oh, it failed. Maybe let's just add these back in. It just complicates everything. So it's a great idea. There's a lot of power here, but I don't like that it's a local solution and you have to futz with it everywhere in your code. So my recommendation in general is to use abstract weights. This is the idea that you are abstracting out whatever your element object is, and then taking the automatic weighting strategy, your automatic synchronization strategy inside that class instead of every single place in your test that you're referencing it. And so this is have a click method that does some kind of weight and then does the click every single time you do click. And this takes, 80, 90% of your flakiness goes away just by making sure every single time you take an action, it waits for the thing that it needs to see. Now, this is another interesting thing, because an implicit wait is waiting at the locating stage, which is technically different from waiting at the action stage. And so, like, I like connecting these where the action is both going to locate and act on what it found. There's two different ways that you can do. There's two different ways you could do it, right? You can either you can always locate the element every single time you click it. Locate element, click, locate element, click. I end up seeing these weird loops in Sauce Lab when I'm looking at people's code where they're like, locate element, is element displayed, locate element, is element displayed, is element enabled, locate element, click, right? So you've sent the same command 5 different times when you only needed to send it once. And that's a very common pattern, especially if you don't really understand your framework and you're calling these other methods that call the other methods themselves. Like, you can have these huge loops where you're just very inefficient code. But the alternative is that you cache it, you store it as in a variable, and then you use that again. But then you risk having like stale element exceptions, right? Like, oh, that element used to be there, but it's not anymore. And this is kind of where I go with this idea of asking for forgiveness instead of asking for permission. This is my advanced recommendation. Just pass in the locator, locate it and click it. If it's not there, if it's not displayed, like, you can't get a stale element if you're locating it right away. But if I guess it's possible that in the microseconds between when you locate it, when you clicked it, something could have changed. But there's a way to catch the errors that Selenium will give you and say, oh, yes, okay, then I know I need to wait. 99% of the time, the element's there, you're going to use it, it's going to be fine. It's the 1% of the time that causes a problem everywhere. And this is performant for those 99% of the time. So you're only actually doing some kind of wait when you actually need to. So my actual code for what I do in this situation is a lot more complicated, but this is just like a very basic example of this will time out after 30 seconds if it doesn't find anything. But in the meantime, it will rescue problems and retry them on your behalf. So that is what I have for talking about Flaky Tub.